Hi, I'm Alex. I'm a software developer with VitalSim, and in this video I'm going to be introducing the concept of a simulation model versus a simulation rendering, and trying to help you make the distinction between where one ends and the other one begins. So let's just start by discussing this from a pure theoretical perspective. So we're just going to talk about simulation in general. So you have something in the real world, and you're putting it into a computer and you're simulating it. So the computer inside is going to be doing some things, running some calculations, and it's going to be showing the results of that to the user. So in really simple terms, the calculations that the simulation is doing, that's the simulation model, and the way that it's showing it to the user and the way that the user is interacting with it, that is the rendering or view layer. So this is usually what the user is going to be looking at, what they're going to be clicking on, manipulating. Okay, so basically the rendering layer, it's going to accept mouse clicks, and it's going to, basically it's a graphic visualization fundamentally, where the model, it's a set of equations, and they're just always running, updating, telling the rendering what to do. Okay, so a user may want to interact directly with the model. So for example, if you're a railway engineer, maybe you don't want to fiddle around with the surface level appearance of what's going on in your controller, and you just want to set a certain internal variable and see what happens then. In that case, it may be easier to interact with it directly with the simulation model. So there are cases where if you're a railway engineer and you're testing a new design, you may want to interact with the rendering in order to have a more intuitive sense and a more intuitive visualization of what's going on. Or you may want to interact with the model in order to have more control and more of an explicit understanding of what the state of the variables are. Okay, so in any simulation, you may have components that combine behavior of model and rendering. So what I mean by that is this icon here. It's kind of bridging the gap, and you can have some things that not only are they visualizing and allowing the user to interact with them, but they also have some behavior themselves. So I'll get to more specifics, but one thing that can be an example of this is a switch machine. So in our software, a switch icon, not only does it render, but it also implements some of the behavior of a physical switch machine. Okay, so let's talk about exactly what I mean by that. So if you have a physical switch on a segment of rail track, it's going to be either in one position, which you call normal position, or the other position, which you call reverse position. So if you are at a dispatch center or an office and you want to change the state of that switch so that your train can get to its destination, you're going to put in a request. And a request is basically a 1-bit command to the site to tell it that you want that switch to change position. The controller, which is on site, is going to decide whether it's safe to implement that or execute that request. And if it is, it's going to send a command to the physical switch machine, which is basically an electric motor, to tell it to move its arm, which moves the points on the track to the desired position. So if that switch machine sees that the arm brought the track to the desired position, it's going to set its sense feedback to the controller to indicate that it's arrived at the desired position. So the office sets a normal request, controller decides that it's safe, sends that normal request to the switch moves using the arm, and then it sets its normal sense line high to tell the controller that it's at the desired position. So this is what's going on at a physical site in a real design. Now here's what it looks like in a simulation. So here's what the user requests are going to look like. So basically we've got some icons, and the user can look at those icons to tell the state of those request signals, and they can click on them to interact or toggle the state of those signals. Now in our simulation you also have what we would call the model or the simulated controller, and that's a set of equations that you've exported from your design software, and we're just executing those equations and updating those tags. So you are going to drag some icons in, configure them to map to one of these tags, and then when you click that icon, it will set the corresponding tag true in the simulation model, and then your model will proceed updating with the new variable state. Okay, so if you've given it a request and your simulated model decides it's safe to move that switch, then it's going to set its outputs. So obviously you don't have a physical mechanical switch in your simulation, so you have to have something that implements the same behavior that that switch would be doing on site. So that's basically what the switch icon does, and that's why the switch icon is an example of something that combines model and rendering behavior. So not only does the switch icon show you what state that switch is in, whether it's in normal position or the reverse position, but it also writes the value of these variables going back to the controller to tell the controller whether what state that switch is believed to be in. Okay, so let's take a look at that, how this all actually runs in VitalSim. So here we have the app Navigator, and this is essentially the simulation model. So we've got a lot of controllers here. I've opened up the controller 3U1AV, and we're looking at the group of tags right here, because these tags correspond to the commands and feedback sent to and from a particular switch machine. So this is a controller, and it's got some outputs and some inputs under slot 3, and they go to the 315 switch, and the outputs to the switch are the commands to the switch machine, and the feedback is the sense lines from the switch machine. So you can see here that it's possible to understand what's going on and interact with it if you know off the top of your head what these tag values mean, but it's maybe not very intuitive, and it's kind of low level, and it doesn't really give you a big picture about whether things are working as a whole. It's just direct tag values, and either they're true or false. So difficult to work with. Okay, now this is what we call the track plan, or the drawing, and in simulation terms, this would be the visualization or rendering layer or interaction layer. So we're not seeing the equations here that actually tell us what the controller is thinking, what outputs are moving, what states variables are in general. We're just seeing a physical representation of the site. Now, we can look at this and we can infer what's going on inside the controller, because all of these icons have been configured to render depending on the state of certain internal controller variables. And that's what you see when you hover over an icon. So you can take the mouse, hover over an icon, and so what we're seeing when we don't hover is just pure visualization or rendering, and what we see when we do hover is kind of a direct view into the model layer so that we can see exactly which tags are in what state, and then we can understand why the icon is telling us, the switch is in normal position, for example. Okay, so let's actually experiment with some of this behavior related to model versus rendering and icons that combine the two. So if we focus on this switch, 315, we can see that it's in what we would call normal position. So this white segment here representing the track is going straight through. It is not diverting. So a user may want to see, is this switch going to respond to a request correctly? Have we designed the controller to act on that request and drive the switch in the way that we want? So we can see this group of controls here maps to this 315 switch. We've got the 315 group of request signals here. So it's currently has a normal request. Let's give it a reverse request. And what we're going to want to see is, instead of connectivity in this direction, we're going to see it now connect and divert upwards in this direction. So we'll hit that reverse request. You can see it briefly flashed red, and now there's connectivity up in this direction, and this is what we would call the reverse position for that switch. So what happened there is me, the user, clicked on the rendering or interaction layer on this icon. This icon has been mapped to a particular tag in the model layer. So me clicking on it had the effect of toggling that tag state in the model layer. That tag state combined with the simulation model told the controller that it's time to change that switch if it's safe to do so. Because there's no trains occupying any of these tracks and a few other things, the controller decided it was safe to change the state of that switch, and it did so, and now the switch has moved. And then, because this icon actually simulates the behavior of the switch, the reverse feedback from that switch has now gone high. Okay, so that tells us that this icon is effectively not just showing us where that switch is at, it's imitating the behavior of the switch machine to control the feedback from the switch itself. Now, as a test engineer for a railway track site, you may want to disable that behavior. You may want to know, like for example, what happens if the switch machine is just physically disconnected from the inputs and outputs on your controller. So as an engineer, you would probably expect that the outputs would go high, but that nothing would happen to the inputs because it's disconnected. So let's see if we can get that to happen. So we have a setting in our software, and that's right here, make switches follow request. And that basically does what it sounds like. It causes the switches to act as an element that bridges the simulation rendering and simulation modeling layer. So if we want to disable that behavior, we can make the switch icon just act as a rendering component, and then we can control what state that switch machine is in. So what we would do is we disable that setting, make switches follow request. And now what's going to happen is if the request for this switch changes, it's not going to do anything because it's like the cables are just disconnected. So let's give it a normal request, and we can see it's red now, and that's the rendering layer. It's saying that this switch is not in the position that you're telling it to go to. So it's gotten a normal request, and the controller has decided that it's safe to move that switch, and it's turned on its output, which goes to the switch machine and would normally cause an electric motor to drive. But we've told the simulation that that output is really not connected to any motor, or that motor is not working effectively, and now it's out of correspondence. So hopefully that clarified to you which aspects of our simulation here are doing something beyond just rendering. So it's not just the switch icon, for the record. There are other icons, and that includes the main other icon that has external behavior is called a search lamp. So that's basically another external machine, and when you send commands to it, it's going to move based on those commands and give you feedback. So that's another element where if you don't simulate that action, your simulation model is going to think that element has just gone dead. So the simulation has to be able to provide not just a visualization for switches and search lamps, but it also has to emulate that machine behavior of a motor actually turning and setting some of your feedback to a new value when you change your outputs. Okay, so hopefully that was helpful, and you have a clear idea of what it means to have a simulation model versus a rendering. And in addition, hopefully you understand why certain icons actually implement certain model behavior in addition to providing just a visualization. If you have any questions, please leave a comment, and remember to like and subscribe. Thank you.